We're going to talk today about linkageless control systems, sometimes called parallel positioning systems, specifically the LMV3 and LMV5. But first, why linkageless? I like to use an automobile analogy to explain. In a boiler system, the building or the process is most like the car. It's the device that uses energy for a purpose. The boiler, which converts energy, is like the engine, while the burner is most like the carburetor, mixing air and fuel. The air-fuel ratio control system, when an old cam and linkage type, is like the float and jets inside a traditional carburetor. Almost no one likes to work on them, and fewer people still truly understand how to make them work properly. The air-fuel ratio control system, when linkageless, is like an electronic fuel management system found on most cars since the mid-1980s. Speaking of the mid-1980s, the 1985 Chevy Camaro offers a great example of this very point. In 1985, the Camaro was offered with a carburetor and a 305 cubic inch 5-liter V8 engine. That combination produced an EPA fuel efficiency of 15 miles per gallon in the city and 20 in the highway, and a paltry 190 horsepower. Now, the Camaro is a good example because 1985 Camaros were also available with tuned port injection, one of GM's early versions of electronic fuel management system. That same 305 cubic inch engine with that same fuel efficiency could produce a markedly better 215 horsepower. That's an 18% increase in power by simply improving the air-fuel ratio control. Remarkable. Sure, we look at it a little differently in burners, but the point remains. Improved air-fuel ratio control results in more efficient conversion of fuel to energy, whether it's being done to smoke the rear tires in a Camaro, create steam in a boiler, or to anneal steel in a high-temperature furnace. Emissions control is another reason people will often use linkageless systems on their burners. In this age of increased environmental awareness, burner emissions are under more scrutiny than ever. States like California, Oregon, and others regularly require burners with single-digit NOx emissions. NO and NO2, or NOx, is created because of incomplete combustion. Much has already been written and said about this topic, but suffice to say that experts in the subject all agree that precise air-fuel ratio control allows for the least amount of NOx production for a given burner design. And in an attempt to fight climate change, New York City recently passed the Climate Mobilization Act, which requires significantly reduced carbon emissions from buildings beginning in the year 2024. Other large cities are expected to follow this lead. The only way to reduce CO2 emissions is to burn less hydrocarbons. One of the easiest ways to do that is with precise air-fuel ratio control. So let's discuss precise air-fuel ratio control in a common steam boiler upgrade project, similar to several that we've assisted with over the years. An old jackshaft single-point control, as shown here, uses just one modulating actuator to manage the air damper, gas valve, and oil control valve. Quite often, boilers like this cycle far more frequently than they should because the low fire gas setting is handicapped by the low fire oil setting, even though oil is a rarely used fuel. Excess air at low fire is almost always higher than it needs to be to support clean combustion, and the 135 ohm slide wire control for burner modulation results in poor proportional only pressure control. Replacing this system with a linkageless control improves not only the hysteresis in the jackshaft system, but also several other built-in inefficiencies in this type of design. Let's talk a bit about those built-in inefficiencies. In Europe, where fuel efficiency and emissions have been a focus for much longer than they have been here in North America, even their linkage or cam and link arm burners have eliminated quite a bit of inefficiency. This is primarily due to the extra switches in their modulating actuator. A traditional European cam and link arm burner will have between 4 and 7 independent switch positions in their actuator, with the ability to prove ignition, low fire, high fire, home, post-purge, and pre-purge, and in many cases, ignition and low fire for 2 different fuels separately. Compare that to traditional North American linkage burners with only 1 actuator with 2 switches, which can only prove low and high. Additionally, intelligent PID control provides much better set point control, process variable control to a set point rather, and less burner cycling. Compare that to 135 ohm slide wire control, and you automatically have a roughly 10% inefficiency built into the older jack shaft designs. How do these extra switches I talked about help? Well, they help in the same way that closing the flue in your fireplace during the winter helps. When you don't have a fire roaring, that open flue acts as an escape route for the warm air in your living room or in your boiler. The LMV system allows an independent home position at which your air damper can be fully closed, and it can reduce the heat losses through the stack while the boiler is in standby. Similarly, every time a warm boiler purges, energy is wasted. The more a boiler cycles, the more it purges. Now, excessive cycling can happen for a number of reasons, but a couple of the most common are that the boiler is oversized, that the burner can't turn down far enough, and that the low fire setting is handicapped or artificially high due to a reliable ignition set point or a dual fuel like oil, keeping everything set up higher at low fire than it needs to be. Additionally, cheap proportional only temperature or pressure control can exacerbate cycling. The image here is showing the desire, if you will, of a set point to be held, and poor proportional control at trying to do so. Every time you are above or below that set point, you're wasting energy. Quite a bit more at points A, C, and E on the curve when you go so far above and below the set point that you're beyond the burner on and off thresholds. So the solution to this problem? Install an LMV system which has separate positions for low fire, ignition, home, and other special positions, and has intelligent PID control with low fire hold capabilities and other features. Another common problem is too much excess air at low fire. In order to compensate for the hysteresis or the lack of repeatability in a linkage system, low fire is typically set with more excess air than required for clean combustion. This turns your boiler into an inefficient air heater and simply sends energy out of the stack. Now, some boilers run at or near 100% all the time, and in those cases, there's no savings to be had by fixing low fire excess air. But many boilers run at or near low fire all the time, where there's tremendous potential for fuel savings. And how about air-fuel ratio control throughout the entire curve, plus O2 trim? When you have a linkage burner, you have very limited air-fuel ratio control. In fact, you can really only accurately control the air-fuel ratio at 2 points, high fire and low fire. Everything you get in between, you're somewhat at the mercy of the linkage for. Even systems with cams in them and adjustability have pretty significant mechanical limitations and tremendous hysteresis. So the solution to this? Install an LMV system which can control the full combustion curve, 6 highly precise actuators, and a VFD from as few as 2 to as many as 15 points in the range of burner operation. Additionally, you can install O2 trim for large, frequently used boilers. You can install it technically on any boiler, although the return on investment may be a little hard to justify. But O2 trim will add an O2 sensor in the stack and trim either the air damper or the VFD setting to maintain an oxygen set point in the stack and keep your air-fuel ratio just exactly where you want it to be, regardless of changes in ambient conditions. Excuse me. So we have a bit of a savings potential checklist that we go through when evaluating a project. And I won't read through this, but a few things to be aware of as you read through this list. High pressure steam can often handle 10-to-1 turn down. Low pressure steam may not. So you need to be careful to pay attention to that and not condense in the stack. Some industrial process applications have excess air in the process. So reducing it through the burner can provide benefits in emissions, but it may not provide any benefits in system efficiency. And linkageless primarily makes gains by optimizing excess air and effectively using the special positions discussed previously. So if I've done my job properly to this point, I've convinced you all that linkageless control is worth using. But you may ask, why Siemens? After all, other manufacturers offer linkageless systems too. Well, Siemens was the pioneer in linkageless controls. Around the same time GM was putting electronic fuel control on the Camaro, Siemens was already putting it on burners. We've learned a lot about these controls since the mid-1980s and have continued to improve upon those early systems, while keeping the tenets of Siemens' mission clearly in focus. As a result, the LMV is the most widely used linkageless control system in the world. So let's learn more about it. LMVs are available in different types to meet a variety of application requirements. For a simple single fuel application with no FGR, the LMV37 can be a great fit. For dual fuel, still with no FGR, try the LMV36. For single or dual fuel with FGR, the LMV51 is often the right choice. And for any of the above, plus O2 trim, the LMV52 will check every box. Introduced in the mid-2000s and significantly improved in 2016, the LMV3 really fits best on single or dual fuel burners up to approximately 10 million BTUs per hour. The only real limitation on the LMV3 in terms of capacity is the torque of the actuators. We'll talk more about that in a future slide. Think of it like a configurable flame safeguard plus parallel positioning control. Due to its simple operation and relatively low cost, it's a great way to improve performance of nearly any nozzle mix process burner or boiler burner, especially those trying to achieve low NOx. And if any of you have, or if you have customers with recently obsoleted Honeywell control link systems, this is a great retrofit alternative. You can find more information on this specific opportunity by visiting this link or by going to the scccombustion.com website and clicking on Systems. The LMV3 is easy to install, highly accurate, and globally approved, so it can be used anywhere in the world. It includes a configurable flame safeguard, a parallel positioning system, and an integrated valve proving system. It can manage up to 2 actuators plus the VFD, and it does require an external temperature or pressure controller. This is typically done with a 4 to 20 milliamp control signal from a PID loop controller set to the LMV, although there are a few different options available. The LMV36 system is very much like the 37, but it includes 2 totally separate fuel curves for dual fuel applications. It can run up to 3 actuators in total, 2 at a time, plus the VFD. These dual fuel curves can also be used for summer-winter settings in certain single fuel applications. This does require an AGM60 switchover relay, which we'll talk about in the upcoming slide. And like the 37, the LMV36 requires external temperature and pressure control and external temperature and pressure controller. The AGM fuel switchover relay is, we kind of jokingly call it a super relay. It allows 2 sets of POCs, 2 sets of gas pressure switches or of pressure switches in the fuel train, and 2 fuel actuators to come into the relay and be monitored by the LMV, one or the other. So you can run fuel 1 or fuel 0, but you cannot run them at the same time. We also offer it with a stacking bracket, as shown here, for applications where there are space constraints. The integrated flame safeguard in the LMV3 has adjustable safety times. Things like purge, trial for ignition, pilot flame establishment period, flame failure response time, and many more items are adjustable within parameters. It can accept a UV scanner or a flame rod and can enunciate over 100 unique faults. The parallel positioning part of an LMV3 has 9 fuel curve points, plus an additional 3 independent positions for purge, ignition, and home. These independent positions are completely unique from the fuel curve and allow you to make the fuel actuator, air actuator, and VFD settings anything you like for these points. So you can make an ignition point rather, that lights reliably every time, perhaps a little more rich, perhaps at an elevated firing rate, and it doesn't have a negative impact on your ability to turn the burner down. An LMV truly allows you to get maximum performance out of your burner. Now, the actuators on an LMV are accurate to 0.2 of a degree, on an LMV3 that is. An LMV3 will try to control the actuators to 1/10 and often will do so, but due to the position feedback in the actuators, the tolerance band, if you will, is 0.2 of a degree. The AZL23 display, as shown here, is the user interface for the LMV3. It's read-only access without a password, and there are 3 different password levels with various levels of access to parameters and programming functions. It includes a detailed numeric fault history and can display flame signal strength and firing rate. The SQM33 actuators are designed specifically for use with the LMV3. They're available in 2 torques, and you'll recall I said earlier the LMV3 is good up to about 10 million BTUs per hour, and that's simply limited by the torque required to drive an air damper. If you have an air damper design that requires less than 90 inch-pounds, you can use this control on much larger burners if you like. These actuators have an internal stepper motor for very precise positioning and non-contact position confirmation. So the LMV3 always knows where the actuators are while it's operating. This is a safety relevant function to ensure that your burner ratio is where it's supposed to be. There are NEMA 4 versions available for applications that require it. And on the LMV3, the actuators do require greater than 90 degree travel on startup for referencing. What that means is the actuator needs to be able to go past 90 on the high side or below 0 on the low side during each startup to kind of find its home position for the position feedback to work properly. And it's supplied complete pre-cabled with a 12-foot long cable as shown here. Flame sensors for the LMV3 include a flame rod and the QRA4 UV scanner. This is a standard non-self-check UV scanner from Siemens. The UL approval also includes this third-party self-check UV scanner shown here. It's a good option for applications where the LMV3 is a good fit otherwise and continuous operation is required. Now, every LMV3 includes a VFD or PWM blower output for 3-channel modulation control, the 3 channels being blower speed, air actuator, and gas actuator. Just like position feedback on the actuators, blower speed can be a safety relevant variable, and it must be confirmed via a speed sensor in a closed loop fashion, as described on this slide. This speed sensor and speed wheel is easily added to TEFC motors. We've also added it to other motor types and can certainly help you with that. So if you have applications where you need this and questions about it, please don't hesitate to contact SCC. The LMV3 is available with a Modbus module. It's a separate device you can buy so that you have Modbus when you want it. It's RS485 and has a little bit more than 50 addresses available. Most of them are read-only, with one notable exception being firing rate command. You can send that over Modbus if you like. And there's a PC software available for use with the LMV3. It's called the ACS 410. It requires this dongle cable, and much like the AZL, there are different levels of access in the software determined by which dongle cable you have, the user, the service, or the OEM level. It allows you to trend, log, print, and create startup reports. You can view burner status in real time. You can view a text history of burner faults, and you can store a library of parameter sets. So there's no need to program each unit from scratch. This can be incredibly valuable in an OEM production environment when you're building burners or boilers or other systems that will use similar parameters time and time again. It can also be quite valuable as a service tool if you have a boiler room with multiple boilers of the same type. You can commission one and dump all those settings into the others, and rather than starting from scratch, just go into the second, third, and fourth boiler and touch up some curve points as needed. And finally, the AZL23 of the LMV leaves a little bit to be desired in terms of information and user information at your fingertips and a user interface. So SCC touchscreens provide additional benefits such as draft control capability, the ability to connect to a master lead lag panel, the ability to connect to a building management system, and more. For more information on these capabilities and these products, you can find a previously recorded webinar on the topic on SCC's YouTube channel, or contact us at any time, and we'll be happy to talk to you all about them. Initially introduced in 1991, the LMV5 has been through 2 complete engineering overhauls and dozens of minor improvements since. The LMV5 is the linkageless control system that other manufacturers continually attempt to compete with. You can use it on all types of applications, anywhere in the world, with the confidence that comes from working with the innovation leader. Like the LMV3, it's easy to install, highly accurate, and globally approved. It includes a configurable flame safeguard, a parallel positioning system, and an integrated valve proving system. The LMV5 can control up to 5 actuators at one time and is available with an internal temperature or pressure PID controller. There are also versions available with O2 trim as an option. The integrated flame safeguard has adjustable safety times for things like purge, trial for ignition, pilot flame establishment period, flame failure response time, and many more. It can handle an infrared scanner, a self-check UV scanner, or a flame rod. And it provides clear text enunciation of over 100 unique faults. Air-fuel ratio curves in the LMV5 are a cinch. Enter as few as 2 points or as many as 15. If you get started and figure out that you need to add or change points, you can do so easily and in real time. If your burner has a touchy spot in the operating range, perhaps it's too noisy or a bit unstable, you can apply a feature called the load mask to move right through that section during normal operation and all but eliminate it from being a concern. The AZL52 display, shown here, provides 4 lines of clear text for programming and seeing what's going on with the LMV5. It is also read-only without a password, and multiple passwords allow various levels of access. It includes a detailed verbal fault history and can display flame signal strength, firing rate, and actuator positions. Speaking of actuators, LMV5 actuators come in a few different flavors. All of them are accurate to 1/10 of a degree. They come in 4 different torque ranges. They have an internal stepper motor, and NEMA 4 versions are available. The non-contact Hall effect sensor for position confirmation, which continuously provides position feedback to the LMV5, is extremely robust and suitable for high vibration environments. And these actuators are wired on the CAN bus, which has a maximum cable length of 300 feet. Flame sensors for the LMV5 include a flame rod, an IR scanner, which is inherently fail-safe, and the QRA75 self-check UV scanner. The LMV5 is approved for continuous operation with any of these available flame sensors. Modbus is native through the AZL52 on the COM2 port shown here in this drawing. Over 250 addresses are available. And there's a PC software available to communicate with the LMV5. It's different than that of the LMV3. It's called the ACS 450, and it provides a lot of the same benefits we talked about before. Perhaps the most valuable are that you can keep a library of standard parameter sets and simply dump them into a new LMV5 without having to completely program each unit from scratch. And you'll see here an LMV5 control panel enclosure. SCC offers these types of enclosures with enhanced touchscreens that offer additional benefits like draft control, connection to a master lead lag panel or building management system, expanded enunciation for other limits on your boiler or on your process, and monitoring of other boiler room instrumentation and more. For more information on these capabilities, please find previously recorded webinars on our YouTube channel or contact your SCC account manager. So in summary, linkageless burner controls offer myriad benefits. Siemens is the global leader in this space. The LMV3 offers linkageless control benefits at near a linkage cost, and the LMV5 offers significant capabilities for varied applications. If you have any additional questions after viewing this webinar, please don't hesitate to reach out to us. You can email us anytime at marketing@sccombustion.com or contact our main number at 224-366-8445, where we have customer service, technical support, and a slew of staff ready to help you out. Thank you again for joining us today, and have a safe day.